Hello everyone, my name is Mars Falk. It is 12 o'clock on December 1st, and I'm standing in a forest. What does this have to do with my research report? Not much. I just wanted some nice scenery and lighting, but this is a research report for my Behavioural Neuroscience class at Dawson College. This video will be a discussion about Alzheimer's disease, something that affects my family and millions of other families all over the world. I decided upon this topic for my research paper because it's something that's genuinely interested me for a while, and there's been a lot of recent research into Alzheimer's, since very little is known about this neurological disease that affects so many seemingly normal people all around the world. This video will be broken into 3 sections. First off, a basic introduction of Alzheimer's disease and how it affects people, just to get our feet in the door. Then, we'll examine the known reasons behind why Alzheimer's disease happens. The third and final section will discuss potential treatments and cures for Alzheimer's disease, and some exciting new research that has been done that bodes well for future treatments of Alzheimer's. I hope you enjoy. Now, how does Alzheimer's disease affect people? Alzheimer's disease is a progressive brain disease that typically happens because of neuronal damage in the brain, specifically in neurons that specialize in language, thinking, memory, and physical activities. These changes in the brain can start occurring roughly 20 years before symptoms start becoming visible, which makes it incredibly hard to pinpoint and thus treat. Typically, the first symptoms that occur are difficulty with thinking, language, and memory, and the individual may need more care than normal from family and friends. Over time, however, more of their abilities become impaired, and they start to experience difficulty with physical work, like walking, moving around, and often their personality or mood changes. Some people may also wander and get lost, which happened in my family to my great-grandfather, who one day decided to get up and walk across the busy street to feed the cows. Cows that were not there because he had sold the farm years ago. Due to these sorts of symptoms, along with the disease progressing until the individual is bedbound, people diagnosed with Alzheimer's disease above 65 years old often die within 4 to 8 years of diagnosis. I also think it's important to make the distinction between dementia and Alzheimer's. Dementia is simply an umbrella term for neurological diseases that elicit specific symptoms. Alzheimer's is one of these. There are several other diseases under this umbrella, including but not limited to Parkinson's disease, cerebrovascular disease, and hippocampal sclerosis. By far, the most common type of dementia is Alzheimer's disease, with a reported 60 to 80% of all cases being Alzheimer's. So, why does Alzheimer's disease happen? This section is going to be a little bit complicated, so you'll have to bear with me here. Essentially, our current knowledge of how Alzheimer's disease occurs is that protein fragments, called beta amyloids, clump together around neurons, and abnormal forms of tau proteins, called tau tangles, will build up inside of neurons. These proteins, by themselves, aren't harmful, and often regulate important bodily functions. However, due to mutations and accumulation, they become harmful. Because of this buildup around and inside the neurons, it can lead to the damaging and destruction of neurons, which are obviously essential for us to function normally. It is generally accepted that beta amyloids damage neurons by blocking neurons from communicating with each other at the synapse, while tau tangles will stop essential nutrients from being transported to neurons. Other issues that occur in Alzheimer's, like atrophy and inflammation, are also related to these proteins, because once they start to accumulate, immune system cells called microglia begin to attack and clear the dying neurons, tau, and beta amyloid proteins. However, if the number of debris and proteins to clear becomes too much for the microglia, they get overwhelmed, and chronic inflammation occurs. Atrophy, also known as brain shrinkage, will occur because of cell loss in the brain, and neurons dying will cause the brain to shrink. To add even more fuel to the fire, glucose will stop being metabolized as much, since the brain needs glucose to function normally, and brain functions will start to deteriorate. Thankfully, we now have methods to identify these neuronal changes, For example, being able to identify unnatural rates of tau and beta amyloid proteins in cerebrospinal fluid. Another technique is using a positron emission tomography scan, or PET scan, to visualize areas where the proteins have built up. And since these proteins can be indicative of Alzheimer's disease, before symptoms occur, it has proved incredibly useful to be able to identify these proteins in a non-intrusive way. With the exception of sampling cerebrospinal fluid, which requires an invasive surgery known as a spinal tap. So now we're going to talk about potential cures for Alzheimer's disease. We're back inside because I got cold. This section will cover potential cures for Alzheimer's disease that have been recently discovered that show promise for treating this disease in the future. There has been a significant amount of new and exciting research in the past year or so about Alzheimer's disease treatment, and it bodes very well for the future treatment of this incredibly difficult disease. In an article published by Neuroscience News, it outlines findings from a paper released by Lancet Neurology, which describe a procedure done to target beta amyloid proteins in the brain, in a process called amyloid removal-related pseudoatrophy, or ARPA. Researchers at UCL have developed a drug which targets beta amyloid proteins and removes them. However, one side effect that the researchers noticed from this is that brain volume had decreased, hence the pseudoatrophy. However, it was determined that the removal of beta amyloid proteins could account for this reduction in size and didn't cause any health concerns, as far as the researchers are aware. Some have viewed this aspect of the research controversial, since similar research has consistently revealed similar results, but the researchers confirmed that the shrinkage is not a concern. Some other research that has been conducted similarly removes beta amyloid proteins, but does this instead by clearing the lymphatic system, which when blocked can promote an increase in beta amyloid protein deposits. This procedure is called lymphatic venous anastomosis, or LVA. By using a process dubbed cervical shunting to unclog cerebral lymphatic systems, or CSLS surgical procedure, the researchers connected the bilateral cervical deep lymphatic vessels to the veins which decompressed the lymphatic trunk and allowed the lymph fluid to flow from the high-pressure lymphatic vessels to the low-pressure venous system. This then allowed for protein blockages to dissipate and enabled the removal of tau and beta amyloid proteins. In a commentary published by Science Direct, some other methods for clearing these blockages are discussed, including some methods that seem rather unorthodox. For example, one of the methods reportedly used, and I quote, multisensory 40 Hz light and sound stimulation, which affected arterial pulsation by increasing neuropeptide signals, which promoted clearance of beta amyloid protein in the lymphatic system in Alzheimer's disease. This commentary goes over several other potential candidates for beta amyloid removal that I won't get into, but I will link all of the resources used to research this topic in the description below for you to check out. Overall, these seem like exciting candidates for potential Alzheimer's disease treatment, and I would love to see where this research leaves Alzheimer's disease treatment in the future. Finally, this brings us to our conclusion. In this video, we discussed Alzheimer's disease, a progressive brain disease which affects millions of people all over the world, including my family. We discussed the different symptoms which come with Alzheimer's disease, which include difficulty with memory, language, thinking, and physical tasks. We also discussed the difference between Alzheimer's disease and dementia, with dementia simply being an umbrella term for neurological diseases with specific symptoms. We also examined the different factors which affect Alzheimer's disease, which include a buildup of beta amyloid proteins and tau tangles in and around neurons. These buildups affect a neuron's ability to function and create neuronal damage and destruction, which can cause a brain atrophy and inflammation caused by microglia being unable to deal with all the rogue proteins and dead neurons. We also discussed methods of identifying these buildups. Finally, we discussed potential treatments for Alzheimer's disease, which are specifically related to removing beta amyloid proteins from the nervous system, which has been proven in clinical trials to aid in the treatment of Alzheimer's disease and offer little to no unexpected side effects aside from atrophy due to removal of beta amyloid proteins. Alzheimer's disease is a very serious topic that affects millions of people all over the world, and a lot of people are quite frustrated with many scientists, but hopefully by this recent research that's been conducted, you're coming closer to finding a cure for this horrible disease. All resources cited are in the description of this video, and I recommend checking them out for more these topics and why they matter. I've been Mars, and I hope you have an amazing day.